Yeah.
Welcome everyone.
Hey, good morning, everyone.
X Technology is back. So hello. So as you can see, we are growing in numbers and we have new members. And I think today one of the main things is that we want to present our new member. It's Mila. So we're happy to have you here. And I think maybe you could tell a couple of words on your background and something like this.
Yeah. Hey, Mila.
Hey, Mila. I think there might be a small delay.
All right.
Yeah. Anyways, we could do it a bit afterwards.
Yeah.
So here we are. And okay, I think I will.
Hi.
Go.
Hey.
Yes.
Hi. Mila, and I'm a PhD candidate, which works something in between. Probably.
All right.
Cool. Yeah. So great. I think we should jump closer to our current topic. I will slightly change our configuration. Now we're moving to the right. And just a couple of words about X Technology, who we are, why are we here, and how many of us is it here. And by the way, as Mila kind of joined us not so far a long time ago, we are very happy to have new members and new partners. So everyone who is interested in running their projects or helping us to run the projects or just interested in sharing and public speaking or whatever, feel free to contact any of us at any of our channels and we will do something interesting together. Yeah, small native placement. Great. Nice. So X Technology, that's us. Currently, today it's 5 of us. And who we are, why do we do it? Here are some goals that Alex puts here together. So the first one is to learn the technologies. We are still learning, although we have some experience, but there are always things that are unfamiliar with us and we want to get better with them. So the main idea is to pick one of these things and get better in it. Today, Alex will share a bit of his experience and pain, probably. And that brings us to sharing ideas and knowledge. That's also awesome because sometimes you're doing your work alone and you gain the knowledge, but you're always welcome to share and engage more people in it. And even if you think that you don't know too much, like many of us, it's not true. So it's always nice to share. And that's how we could build these new communities, which is also quite awesome. So our community is kind of growing with a normal pace, let's say. We are quite happy with that.
Yeah. Indeed, Igor. Thanks.
Yeah. So, and we're meeting new people, new awesome people. That's always great. That's one of the main goals in life. And we are having fun here. So I hope you will also have fun with us. So I think I will hand over to Alex and he will start his presentation.
Yeah. Thanks for introduction. I actually, I don't know what to add here. Maybe one thing also about updates. So you can see we have now a very important update, by the way. We have now a logo, official logo of X Technology, and during the talk today, you might understand why it's actually important. I'm going to talk today about WebAssembly. So WebAssembly is as a compilation target for PizzaScript because it's this is a project that I'm doing with the X Technology. That's a way we want to go today, and I'm going to talk about in general what is WebAssembly, some key features of this format, and I also will demonstrate some of the examples. not too much, but it's going to be like around 3 or 4. And yeah, cheers to everyone that who joined us today. Yeah, I promise not to name my buddies who joined in the YouTube video. So yeah, I'm not doing that a bit. That's fine.
No blaming.
How it goes. Yeah. So now for today, I hope we will learn a little bit about WebAssembly, understand some of the goals and key concepts of this technology, and also see some of the usage of WebAssembly format. Yeah, and maybe you're interested, how is a PizzaScript doing? So indeed, we have a demo for that, and one of the goals of a PizzaScript was to be compiled to WebAssembly. Actually, that's already next session in this presentation. So what is a PizzaScript? Just to briefly mention that before we go deep into the WebAssembly technology. And by the way, feel free to leave your questions in the chat or yeah, ping us in some way. So I hope our hosts will interrupt me and drop questions so I can answer them. And also for you guys, feel free to just ask during the talk. Yeah, PizzaScript. This is a reminder. It's a toy programming language that I'm working on, and the idea is to just to try out some of the techniques to learn a bit of theory and also practice with Go. So actually, one of the first goals is that I'm chasing is to learn Go language, and specifically by using some popular libraries like RxGo in this case. So RxGo is a reactive patterns library with which I'm trying to introduce streams in my during phases of compiler of PizzaScript, and we explored it a bit in our last 2 sessions. Also, the goal is to learn a bit about how the programming languages and compilers work in general. And actually, I was learning it during my time in university, but that was already a super long time ago, so I don't remember almost anything from there. So it's kind of exploring from scratch almost. And yeah, indeed, the last goal was to experiment with WebAssembly, because the original idea was that we have some programming language and we want to execute it in browser, for example, but actually it's not limited to only web browser. Yeah, and I always was paying attention to this WebAssembly technology, so I thought that would be a nice opportunity to learn more about this format. And yeah, that's already a 3rd session today. Just to remind ourselves, last time we talked more about the compilers, the compiler and parser stage, and we discuss this Pratt parser algorithm. You can see this pseudocode. If I'm not mistaken, no, this is not PizzaScript, by the way, but I have a PizzaScript version of this algorithm. So that's in short version of Pratt parser algorithm that converts the tokens from a lesser phase of a compiler into IST, abstract syntax tree, that contains information about your current program, and that's how it looks in a simple representation. And if you remember, when I was working on that with RxGo and with my own implementation, it actually became a bit more complex. Just quickly show you that. We called it the pyramid of doom, if you don't remember. If you remember that, yeah, that's this huge guy. So you can compare it with what you see on the left. It's quite a difference. And to be honest, I wanted still to generalize some of these functions. So probably next session gonna be about that. Anyhow. So for today, we go to a very exciting topic, which is okay, we discussed the lecture of our PizzaScript, we introduced PizzaScript, we parsed PizzaScript into IST, so now it's time finally to compile it to WebAssembly and to run it in the web browser. And that's kind of challenging matter, I would say. So let's talk about first what is WebAssembly, what we're talking about here. So WebAssembly is bringing other languages to web since 2014. Yeah, it's almost true. Actually, I'm going to talk about history in a few minutes. But in general, the idea is that the web always been, and it still is, containing one or embracing one specific programming language, which is JavaScript. But there are so many other languages, and there are so many written programs in other languages that people always thought that it would be nice to actually transpile. It's another term that we use very often in this matter, that can be transpiled to something, even maybe JavaScript, that can be executed in browser, and then you can really use the programs that already been written in a browser like they were written in JavaScript. But yeah, that was not the case all the time. So we had only JavaScript, and that is the official language of the web, I would say, until we introduced, or they introduced, WebAssembly format. And WebAssembly is indeed the format that allows you, as a programmer in other language, to compile something to WebAssembly and then execute it on a browser environment. And yeah, that's very simple as it is, this idea. Yeah, so as you can see, there is this nice picture where C, C++, and Rust is some modern system programming language that can be also compiled to something that is called IR. IR is intermediate representation, as we might learned from last sessions as well. And then it's compiled to WebAssembly, and on WebAssembly it can be executed in browser and can be executed in other environments. So yeah, that's simple as that. The idea, I mean. Let's have a look a little about the practical side on that. So to look at the code a little. That's three different sections of code you see here. The first one is the C function. Basically, it just it doesn't do much, as you can see. It's just it does a sum of two integers, and then what you can see in a middle screen, it's a representation in a WebAssembly format, or to be specific, it's called a WebAssembly text format, or WAT format. And if you look close enough to that, you actually will recognize some of the things that we saw on above paragraph in here. So you see the function add, for example, and it contains two params, and the params even has a type. Well, this is integer 32, and this is integer 32 again, and it also returns integer. So yeah, they are quite matching. And in the end, the last screen in here, this one, it shows how you can use it in a web browser. So yeah, that's the original program that we had, some code written in C, C++, Rust, or any other languages. Then we compiled it to something like that, some intermediate representation, and then we basically want to use it in the web. And that's how we do it. We just use some JavaScript API like that. So we instantiate the module. We're gonna talk about this more later. So we instantiate this module, and then we use this exported function, and we just call it with the arguments, and we get a result. Yeah, I think the idea is kind of straightforward, but I wanted to demonstrate it now. So for that, I wanted to also show you that thingy in here. So this is web explorer of WASM, so an online tool that helps you to do some playing with WebAssembly. I will shortly do a full screen in here. So yeah, this is a simple web interface to play around with WebAssembly. So you can compile some C and C++, and you will get some a little bit different result in here. But in the end, it's the same function called a bit differently with two params and returning still integer. And what it does, it's calling the i32 add. If we compare to this guy, it's exactly what it was doing. Yeah, and then what this tool allows you is basically to download this WASM file, and in idea is that I can just run my server, make some simple HTML page, load this test.wasm file in there, and that will work. So let me first try to demonstrate my prepared example, but then we can maybe do the same with this test wasm as I have it. So the first one, it's exactly this function, the first demo I wanted to show, but on my index document. And you can see I have prepared already these WASM files up front, and this is a nice dev tools by Chrome. Some people I know use it a lot, like Igor and also Dima. I am pretty sure familiar with this tooling, so I will not discuss that. Let me actually do that first, and I will reload the page, and that's my JavaScript code that you can see here. It's yeah, it's just some simple document in there, and you see don't have anything else. The rest of the code is commented, and then I'm doing. And then I'm just using some web API in here. I'm instantiating the module, and the idea is that I can add numbers in, and these numbers will be added in this that will come from a WebAssembly environment. So yeah, I will put my debugger in here, and you see I am receiving something that is called an instance. We're gonna talk about that in short. And I have a function, and let me execute this function. Okay, I will open the console. And yeah, you might wondering why the 1 + 1 results in 9. I think it's kind of logical. No, it's just I was experimenting with my modules in there, and yeah, that's the example I got. Yeah, maybe I can show you this test wasm. But also, it's yeah, that doesn't matter too much. I think you will trust me that it will just work as is.
And actually, I definitely trust you. Maybe we could just give you a small break.
Yeah, please. Yeah, sure.
Yeah, before you jump to the next exercise of yours.
Yeah.
Yeah. So there are first of all some questions in the chat. I think.
All right.
Put it here.
Exciting.
So, yeah. WebAssembly is just for browser or also for Node? I'm not sure if I even understand the question, but
yeah, it's a good one. I I can guess who that. Yes, exactly. It's the beauty of this is that it can be executed on many environments, and in case of Node, because Node is using V8, and V8 is somehow an engine that works also in a browser, in Chrome browser. And the V8 is an engine that can execute JavaScript, and it was built in a way, WebAssembly, I mean, it was built in a way that it will be just be called on the same engine, on V8. And that means that indeed we can call it from Node, and I will also demonstrate it in a bit.
Awesome. Yeah, and in the meantime, there's a second question, which is, yeah, where does the code execute? I think you might have mentioned it, but honestly, I'm so lost that I probably answered.
Yeah, it's a valid question, I guess. It depends on what we mean by which part of code is executed where. But the idea is that it's all happening in a well, in not a JavaScript environment. It's a bit a deeper level of a JavaScript engine. So it's executed in a context of just this web page, let's say like that. And it also means that it's executed in some sandbox that JavaScript is executed on. So that means that we already go into one of the goals that was for designed for WebAssembly. So it should be a very secure environment, and it's the same secure as a web itself. So it's the same environment where JavaScript is executed.
Nice. Yeah. So just for me, it's kind of everything that happens in the browser, right? So
yeah, absolutely. I just showed this. So this is indeed the web page, and it's only dependent here on external file at the WASM, and this is a web API fetch. So I load this file, and then I have an API to instantiate this module, because it's called modules in WebAssembly. And then I can execute all that was exported, all the functions I had that were exported from this module, and yeah, I can freely call them and do whatever I want. Indeed, that's executed in a browser.
Yeah.
Alex,
Thanks.
why is it that much faster or more performant than JavaScript itself?
Yeah, I expected this question, but let me scroll down a bit. Do I have something about performance? I think I removed a little bit. Yeah, I have only this chart for now. Yeah, the thing is, in short, it's WebAssembly is not much faster than JavaScript, and the idea is that your JavaScript ideally would be executed with the same speed as WebAssembly, but JavaScript is a very dynamic language, and when V8 or any other engine is executing JavaScript, it needs to do all kind of optimizations to make it run faster and faster. WebAssembly, on the other side, is a very strict set of instructions. It's can be it's called assembly, so it can be compared to assemble code. So those are very strict instructions, very limited number of formats or types that can be executed there. So that means that a browser or any other engine that executes WebAssembly knows exactly what time or how many ticks, like processor ticks, would it take to execute your program from A to B. So that means that it's absolutely predictable compared to JavaScript. And JavaScript, on the other hand, is very dynamic, but it's not predictable, and it very depends on a browser implementation, on many things. I can just underline that with a simple example. In JavaScript, you have this prototypal inheritance, right? Doesn't matter if you know it or don't know it. So it means that your objects can grow, can shorter all the time, and the browser does all kind of optimizations. It introduces some intermediate classes for that, because the intermediate representation, as I remember that correctly, sometimes it is a C++ language. So you have to introduce new classes, and it kind of helps, but it doesn't help with the predictability and with performance. So ideally, your JavaScript will be executed with the same speed as WebAssembly, from the nature, and it's very pretty in terms of speed as well.
All right. So what I understood is the predictability is the main key. All right. Cool.
Yeah, exactly. But it also also usually faster than JavaScript. So JavaScript should be the same speed, but usually WebAssembly is faster because of the things that we mentioned. Right. Let's move on, I would say. Okay.
Alex, maybe before you move on, there's another question, and we could answer it now.
Absolutely.
And then jump. Yeah. So is WebAssembly a typed language, or does it need an external support to make it typed?
It's typed language, and I will talk about that in 5 minutes, if you don't mind.
So feel free. Yeah.
All right. Let's move on. I would say the history of WebAssembly, just a brief one, and the next session is going to be much more amazing, I think. Actually, let me already do some of this stuff that I wanted to show you, because right now you will see some magic. It's Windows 95 started in a web browser. Wow, how cool is that? That's why I'm starting it now, because it will take some time to start it up. But this guy is already running now. We can just spend all of the time that is rest just for playing the game. I guess it's Let's not do that. I will share a link, and I can find this in a presentation. It's already in there. So about history. I will not dive too much into details, but it's all started a very long time ago, and it all started probably with Google Chrome. They wanted to have a very performant execution of code in a web browser, and as we said, the JavaScript was the only language that can be executed in there. So Google introduced the solution called a Knuckle or P-Knuckle, or native client, or a portable native client to say, and this was a way for a browser, for Google Chrome, to load some compiled C++ code and then execute using the API of the browser, execute this code inside. And that was working fine. Actually, they still have a tutorial that works in your browser, and it's very simple tutorial. However, it has some limitations. Like you cannot call a JavaScript API. If I remember correctly, I did it once a while ago. It's hard to combine these two worlds. It's basically you're executing some C++ plugins in your browser. That was a great project, and I think it's deprecated, but it's still working in Chrome. Then, on the other hand, Mozilla was playing a bit with the ASM.js format, and ASM.js is it's a different approach, but the problem that they're trying to solve is the same. They wanted to have a very performant execution of JavaScript in a browser, so they introduced this experimental project ASM.js, and let me find some example of how just JavaScript looks like. I usually, this is an example. So this is just a JavaScript code, but with some adjustments in there. So this is JavaScript. You see, it's using some binary operations, like I'm doing the OR operation with a 0 in here, and that's a byte OR operation. And that what they wanted to do with these slight changes is basically, when you do something like that, that means that you wanna operate only with a small integer types, and that's what ASM.js used in their project. So what they did in this project, they introduced some mode in your browser, which is comparable to instruction use strict in a modern JavaScript. So in JavaScript world, we have this instruction use strict, which allows you to change the environment in which JavaScript is running. So basically, it secures your current JavaScript environment. It limits you to not use some global scope, for example, and so on. So they did the same. They introduced this use awesome instruction, which started the mode of executing ASM.js. And basically, in this mode, they were looking for these optimizations from JavaScript, and they were interpreting more performant code in a browser. So that was a second approach of achieving something like that. That was done by Mozilla, and somewhere in 2014 they started collaborating with Chrome, and actually that became a WebAssembly project. So that was a start of this WebAssembly project, which officially started in 2015, and since then to 2017 they introduced the first minimum valuable product version, which is currently working in the browser, and is already going forward, as you can imagine. So in these times, the working group was introduced, the specification, the first version of specification, the specification working group. That one I mentioned before. Official logo, that's a very, very important milestone, as you can see. And finally, in browser preview, in 2017, they achieved this goal. So now all the main browsers support WebAssembly, and we can execute it almost in all environment that we want. I mean, in all modern browsers, let's say like that. So starting from that, the idea of this working group is that they grabbing feedback from execution of WebAssembly. They basically looking forward to what is the most important for community to work on. And I will say one thing about that later, like what features it has. That's a bit. Have a look at our Microsoft Teams running. It seems that it's running. Okay, so it's better. It's actually now executing something like, I don't know, is it a secure mode or something? But I mean, this demo is already amazing, I would say. But if that goes well, I will show you one more thing. It's even more interesting. Meanwhile, our this thing is started to working, I guess. Just I cannot see my cursor, I guess it's because it's captured by this video in here. But basically, this is a start of a game, I guess. I need some time to start the demo. I didn't want to play the game here. Okay, still running both. But by the way, this is a perfect time to ask questions if you want. That's fine.
And play Doom, I suppose.
Yeah, Doom 3 indeed. Yeah, I was switching between these two tabs. We're almost there. It's even can start sound, but I'm not sure if you will listen.
It was running as Candice. It was so fun. I already almost forgot what it is.
Yeah.
Like when you switch off your PC not properly, it runs as Candice.
I like it. I think it doesn't work all the time, but it's just amazing. Like what they did is just they took the original code of Windows 95, transpiled it to WebAssembly and starting in the browser. I mean, that's already cool. Even if it doesn't start all the time, and actually it's quite stable. You see that in Doom they did the same, and I think these demos are just amazing. They show how powerful is WebAssembly technologies.
Are you gonna play?
Maybe it reduces your performance that you have other tabs open, or is it not relevant?
No, not in the scope that I wanted to show, to be honest. Yeah. Okay. Yeah. Let's not play all the. Yeah.
Actually, yeah, I had a pretty general question. So I forgot how many years ago was it introduced? Like something like 5, 6? WebAssembly.
Oh, I think it's also almost 10. I think, yeah.
Yeah, 10. Okay, yeah. So then the question is it a real competitor of a JavaScript world, or they kind of exist in parallel? And
yeah. Yeah, it's also a very popular question in the WebAssembly world. Yeah, I think, no, they're not competitors. It's an addition to JavaScript. I like to think about WebAssembly as, yeah, exactly. That's a technology that brings you a way to execute other languages in web, but doesn't mean that they can be competitive or so. Yeah, it's an addition, let's say. It's adding some of the features that you can use. Like for example, yeah, if you written your zip library in C and C++, why would you write it in JavaScript? You can just use it that makes sense for you. I have another here. Let me show that, and after we can switch to other topics, because we still have plenty of information to talk about today. So this is another example. For that, I will also do something funny in here. So I will open the OBS. You guys know my vibing cat example already. So yeah, that's me. Hey. Oh, actually, I can do it like that. So that's a browser capturing the video, right? And I just start a virtual camera now. Now I appear in the browser, you see, and that's the WebAssembly. That's where we can start WebAssembly, and basically it's applying some filters to the video, and the filters also just converted C++ filters applied to the video. Yeah, I like it because of this example, because of simplicity. And I just because I mentioned vibing cats, I think I should show them, right?
Mm-hmm. So in the meantime, yeah, there is a question from our listeners. I think first one looks like this: do all the WebAssembly files have to be built in advance? And then there is like, in other words, can I write arbitrary code in C, Go, Rust, etc. in browser and run it in browser immediately? Or it has to be built in advance?
I think I got a question. Yeah, the thing is, you can do it on the fly. can you hear me? I heard some
Yeah,
voice on my. Yeah. Okay. Yeah. You can compile it on the fly. I mean, you also have an ability to write your compiler for Rust in JavaScript, right? And that will produce the WebAssembly model. The thing is, you will need this compile stage anyways, and you still can do it in a browser. So it can be built ahead of time, or it can be built in a browser, but this build step should be performed for now.
Okay, cool.
Yeah,
so
I will turn this tab off, I think. Yeah.
The stage
Shall I
yours.
continue? Yeah, okay, good. Good. Yeah, I don't know if this will start in the end. Feel free to try it. I wanted to show one funny thing about that. If we have some other time of questions, I will continue. All right, so this is kind of funny use cases and the examples, but I think they're really, yeah, the most important of this format is that you can indeed run any code written in other language in a browser. That means that you can transport other libraries and important functionality into a browser. That's first. And second, indeed, there are some performance advantages of using WebAssembly sometimes, but that's very dependent on the project. So I know many projects that are using video a lot and using some calculations that can be video related calculations or image related calculation. So projects like Google Earth, Google Maps, and other analogous of that, Yandex Maps. I heard many talks that they use in WebAssembly for performance reasons. Yeah, I hope that makes sense. Yeah, that's current support. So you see main browsers now supporting most features of WebAssembly, and I will talk about these features in a second. Yeah, actually this has a very nice addition to what I said. Well, first, this is a page that shows all other languages that can be now transpiled into WebAssembly, and you will see this list is huge, and also it contains some really extreme examples, like JavaScript can be compiled to WebAssembly. Java can be compiled to WebAssembly. Yeah, this guy here is showing that it can be, but probably you should not do that. Yeah, that's a funny thing. And even TypeScript can be compiled to WebAssembly. And you see, TypeScript is actually very natural to WebAssembly world. The thing is, TypeScript it's a superset of JavaScript that is compiled normally to JavaScript, but also TypeScript has a subset that is called assembly script. That's a bit side talk, but just to finish it, assembly script can be just purely compiled to WebAssembly, and that is also very nice of it. But yeah, go into this. So back to WebAssembly, the design goals for this format was to make it fast, so to be loaded fast comparing to JavaScript, to be faster than JavaScript, and to be executed faster than, or at least the same speed as JavaScript. Safe, so they're using the same environment as the JavaScript does, and it's considered to be safe, and it's improving all the time. And also it has, JavaScript in a web environment, and therefore, WebAssembly also has an access to awesome web API in some way. It's not a direct way. We can explore it a bit later. Modular, you can separate your code as much as you can, and that helps with the development. Efficient, same as fast and performant, I guess. And platform independent. That's very important, I would say. So we said the first version was delivered in 2017. It contained the modules, the idea of WebAssembly modules that contain these amounts of code that you can execute some functions, and it has some hidden functionality of module itself. So it has an internal functionality, and it has exported functionality that can be called from outside. They had introduced a binary format. That's a WASM file that we downloaded from this WASM Explorer, as you saw, and that is the one that can be loaded now using the JavaScript API to your execution. They also introduced text format, and that's what we saw in the first place. This guy here. So this is called WebAssembly text format, and you can see this is human readable, and the WASM format is a one-to-one reaction to this format. So basically, WAT and WASM format they're as much close to each one as you can just go from left to right and immediately transpile left WAT format into WASM format. So they are interchangeable quite easily. Right. Yeah, and executed the same universe as JavaScript. So that's it. So that was a scope of MVP since 2017 in most browsers. So work is going, of course, and I think the most exciting news from last year, they introduced threads. They supported threads in a browser. As you know, the browser environment has a worker threads, something like that, and the worker threads is a way of you to execute JavaScript in parallel, because usually it's not what a JavaScript does. So execute JavaScript in parallel, also share some values between these processes. So that was a very nice feature that they supported, because many libraries, as you can imagine, many code written in C, C++, Rust, using these threads for performance reasons. So that's already supported in most browsers as well. What is not supported, yes, but under discussion and under investigation, and actually I saw a current example of Java that is using the garbage collector. So the idea is that they want to introduce in WebAssembly the implementation of garbage collector. So any language that uses garbage collector internally, like Java, like JavaScript, and many other languages, they will be transpiled or compiled easily to WebAssembly from the box. Right now, it's not the case. However, you can still transpile or compile your Java or JavaScript to WebAssembly. And how they do that? Well, you can compile your garbage collector to WebAssembly too. So yeah, why not? That's I like the ideas. Why not of that? DOM access, still discussing how can we access DOM from the modules. So right now you have other ability of importing something like JavaScript methods into your WebAssembly modules, execute the function in a JavaScript environment still. And yeah, we will not get support for all browsers, so that's said, but that's what is about. You can still have like mimic environment written in JavaScript that has a polyfill for WebAssembly, but I guess that doesn't have much sense. So yeah, probably that's a constraint we have to live with. It's not going to be supported with all browsers. Okay. Yeah, so just one word about stack-based virtual machine, because that's what WebAssembly is executed with. So basically, this format of WebAssembly is using the stack-based virtual machine. That means that simple thing. It doesn't have idea of I forgot the word, of processor, smaller storages of data. Maybe you can guys help me. Small and very performant, whatever. So the idea is that you have a stack of that where you can push your data, and you have another stack where there are instructions of your code. So the instructions are very simple. You can put your code, or you put your data into the stack on the left, and then you have instructions to, for example, to multiply or to sum this data, and it will just take two integers from the top and produce something to the stack on the left. So that's basically just a model how the code is executed in this WebAssembly virtual machine, stack-based virtual machine. Yeah, and we almost, by the way, finished with this theoretical stuff. Well, no, I see lots of stuff still coming, but yeah, we on at least in the middle of that. So yeah, what currently supported with WebAssembly as a format of it, it's two types of integers, i32, i36, float of 32, float of 64, and yeah, different operations with that. Of course, all the control flow sentences that you need, if loops, while loops. Yeah, we had a call yesterday where Dima said it's limited, but yeah, he heard it is very limited. But in fact, you can do any program with just using if-else statements and a switch and a while. So yeah, it's a full syntax that allows you to run any program basically. It supports functions, internal functions, and you can export functions, and some memory management, however, in a safe way. Yeah, it's out of the scope for today to discuss the memory in there, but yeah, you have some model of or an API of memory, so you can introduce new pages of this memory. You can store something in there, and it's not persistent memory, as you can imagine. It exists while the WebAssembly module exists, so just a short period of time, and this memory is isolated from other memories. So the safe idea is still there. WebAssembly API for JavaScript world is very tiny in here. However, it supports all of these needs, or it can first, these three functions help you to instantiate your model in a WebAssembly format, and also you have idea of what is module, what is instance, how to make new memory pages, and yeah, how to search something in there. That comes with the other demo, and this one also going to be very simple. So in here, what I'm doing is basically showing that you can execute your JavaScript functions inside WebAssembly modules. Well, that's a different story, right? So imagine we have this WebAssembly formatted module, and how we can read it. It says I want to import function import1 from if JavaScript provides me that. Of course, that's the way how you deal with the JavaScript environment here. It also imports the import2 function, and it introduces the main function that is going to be structuring your model. So that's where your main function starts execution. What it does, it says, yeah, I'm going to just call the first function, and I will also export the function f that you can execute on JavaScript world, which will call your second function. That's yeah, that's a way that shows that yeah, your WebAssembly will execute something that was provided by JavaScript. It will provide you the other function that will be calling the other function of JavaScript. Yeah, that's a very nested example, like we usually have in this this wall. It's still going here. Okay, let me show you quickly this demo then. So as you can imagine, it's going to be very simple as well. So what we're going to see is just a hello world here. I have a debugger sentence in here, which will stop my execution. So we see that when my model loaded, it already just executed the first function that we provided. So it called this hello, console log hello, that was executed. And then I'm calling the exported function f, which does the rest. So hello world. That's easy as that. Yeah, and this is a thing that wraps functionality into modules. That's a very tiny stuff. And just a side remark is that there is a proposal in WebAssembly that you will be able to someday, hopefully, to just load your WebAssembly files as they were your scripts, like that, and you will have this functionality available without all this additional code in there. But that's not working right now yet. Okay, we almost finished with this part, and we almost into the final talk about PizzaScript. So this is just me explaining some of the compilation and tooling, and actually I'm not gonna talk much about compilation. I think we discussed some of the details already. Just a few mention of the tooling. So there are two main packages I would mention. Scripting that helps you to parse and compile C++, and other code to WebAssembly. and the WAPT tools, or the WebAssembly build tooling, that helps you to, like transpile your WAT format into WASM format, vice versa. I can also produce your C++ or some C++ code from WASM modules. So some tooling around that helps you to play with it. And I'm not going to explain this whole bash script. Basically, it demonstrates what should you do to install these tools for you locally if you're using a Mac or a Unix environment. So it's not that hard, but all the tools are unique, and they have different installation passes. So be careful with that. Yeah. We're almost there. Just 2 or 3 demos left. Well, last one I wanted actually to show also about performance. We touched this matter already, and just to show you that's also the demonstration where we're gonna be executing WASM, but not from browser, but from Node.js. I have this Fibonacci example. Let me open it in here. So what I'm gonna be executing is this shell script. And the shell script demonstrates, well, first of all, I have a.out, which is a compilation step of Fibonacci. Oh, 1 second, I will open it. Fibonacci.c. Yeah, to show you that. So this is the first that we are running is Fibonacci in C. So we compile this module upfront just into C executable, in executable from C, and that's the first what we want to compare with. So just this guy. And I'm outputting the statistics in a Node.js because I want to compare it with Node.js basically. So don't look at that; it just will show some number. And that one was for, I don't remember what, I think it was for purpose there. I will believe it. Yeah, and then I'm calling 2 other functions. First one is doing the WASM comparison. So what it does, and you see there, I'm loading in Node.js world. I'm loading the WASM file, and it's even easier than in a browser world. I'm just can read it synchronously in this case, and I'm instantiating that, and then I'm just running it in a similar way like we did it in browser. So I have instance, I have experts, and then I'm calling the Fibonacci number. Last one, I'm doing the same, but now with a Fibonacci.js. Oops. Now I have this small Fibonacci function in JavaScript. So what this does just recursively goes from top number to small number until it produces all the Fibonacci numbers on the way. I used the number 42 in this case. So it's big enough to demonstrate. All right. So Fibonacci, let's call this guy. I'm gonna go in there, I guess. I'm gonna call it like that. Fibonacci.sh, this guy. So it would take some time. I would expect like a half a minute or so. Meanwhile, what's going on in here? Yeah, it's still loading. I'm not sure if it will load in the end or not, just for fun showing it in here. Yeah, so that we see that it's already executed the first one, which was a C version, just compiled C version of my Fibonacci code. Same number. This is a produced cluster that was on a 42 step. So the second one was a WASM version, and the last one was JavaScript. And I think this shows some weird stats. I don't know if you agree or not. So the first one shows like 7 seconds, almost same as a. Wow! I just got a sound from Windows starting. That's amazing. Yeah. Let me finish with that first. So yeah, you see the numbers with a.out C compiled version and JavaScript are almost the same. And actually, that's very surprising, right? Because WebAssembly took almost twice that time. So yeah, if you thought that your WebAssembly always executes faster, that's not the case. And I don't have good explanation why we have these numbers in here. I mean, yeah, I can imagine that JavaScript executing some numbers calculations is very performant. So that explains why this and these numbers are almost the same. So why it took so long to WebAssembly to load in this case? Well, I guess it's yeah, it's some WebAssembly in environmental startup issues that we had in here. So in general, it should be faster, but we see that's not the recipe all the time. So you have to be careful, of course, and that also shows you that. Oh yeah, and now I have my Windows example. Yeah, sorry, I'm jumping from one to another, but actually that's what I wanted to say about performance. So now let me finally show you that, and that's, I think that's the most amazing part about WebAssembly. So how cool is that? We start in Internet Explorer in a Chrome browser, and the Internet Explorer version, I don't know, 2 or 3 or something. And then now we will try to actually yeah, go to internet and execute some website. Well, if that succeeds, I actually have a doubt in that. But feel free, always feel free to try it yourself. I think it executes faster. Yeah, Igor.
Yeah, I mean, not that I'm gonna try Windows. It's 95, right? Or which one?
Yeah, exactly. It's Windows 95.
And you heard how it sounds. So regarding the previous example about Fibonacci, there is a comment.
Yeah.
Just in case, was it the same argument that you passed to WebAssembly? And
yeah. You see, the produced result is the same, so that shows that indeed this is the same numbers.
Yeah, and actually, I also
No, that's it. Yeah.
Yeah, I also had a question regarding it. So as I understand, all the browsers are optimized for JavaScript because it's just the standard of web development.
Yeah.
And speaking about WebAssembly, how safe is it to introduce to your website code so that it won't just halt or stop all the client applications on their machines if their machines are not too performant? So you said that, sorry again, so Google Earth is built with these technologies, right?
Yeah. So the idea is that indeed the WebAssembly is gonna be faster in than just running the JavaScript. But as we see that that's not all the time like working like a rule. It has to be some specific task, and you need to know basically when it's better to execute WebAssembly, your code as WebAssembly, and in some cases, like writing a web application, like a JavaScript application, some website with a code. It's in most cases you don't think about WebAssembly, but still you can have some helpers in the background. And I can imagine, for example, that in JavaScript there are different kind of functions that you can execute to help you with the development or with the running your code, like that can happen in the background. So what I'm talking about is some, for example, build tooling, like you have some Webpack that compiles your JavaScript into one big bundle of JavaScript. So all kind of that stuff that just don't have to call your document object model API. This all can be transpiled to WebAssembly, and it's safe to transpile to WebAssembly. And in theory, in most cases, it should be faster than pure JavaScript.
Yeah, I can say just I heard that there is this library TensorFlow for deep learning, and also there is a version for JavaScript, so TensorFlow.js or whatever. Why did they go to this direction if WebAssembly exists?
I think they did. I'm pretty sure they did. I think nowadays these kind of solutions, I think they already embrace as much WebAssembly as they can, because it's already a very stable technology, and it shows very good performance results, and you don't have to write your code in JavaScript. You just transpile it to WebAssembly directly, and then calling it from JavaScript. So yeah, that's I think that makes perfect sense for TensorFlow kind of libraries to use WebAssembly from the box.
So they're already using them. Okay. Cool.
I think so. I mean, I don't know. Yeah, I would imagine that. Yeah.
Yeah.
All right.
Cool. So we can step
back. Yeah, let's finish. You see, we're really close. It's almost in there. Just yeah, just like 50 minutes left, I would say. It's like no, it's kind of funny here. So yeah, I didn't talk much about tooling because yeah, that's very difficult stuff, anyways. But you saw this. Yeah, you have to play a bit with it to feel comfortable how to build your C++ model to WebAssembly. So, anyways, I'm writing this PizzaScript, and I'm writing it in Go, right? So you might ask, all right, what Go does with WebAssembly? What's the thing? Why didn't we write in C++? Why WebAssembly? So the thing is, with Go and with all as with many modern languages like Rust, for example, you have many things from the box. And in Go case, you have just Go build, and you can specify flags that you want to execute it in JavaScript environment, and your compile target for your program, just Go program, not talking about PizzaScript now. It's gonna be WebAssembly, and yeah, then that you have your WebAssembly model produced with just this command. And yeah, for that I introduced actually in my project WebAssembly.go. So that's just a separate package in here, and it's very simple. It's you see, it's just it's pure Go code. What differs from pure Go code is import of this model syscall.js, and that's what helps Go build command and to glue basically JavaScript and WebAssembly world. So that's the thing that we saw in HTML example. So things like that. This is very low-level API, right? And sometimes you need not only that, because this is just a JavaScript API, right? But you also want to have something to help you execute WebAssembly code, but with the environment that you write in your program. And so in this case, we want to have a WASM program. That's fine. But sometimes we want to just use known features of Go itself to provide something in your browser environment. And that's what the syscall.js model does here. So we just import it as Go because it's Go program in here. And with this, I say that, yeah, when I compile to WebAssembly, I want to introduce a method in a global that is called print message. And that's just a combination of this model that I import in here. It's internal produced code, right? And Go build tool that will build something for you together with a JavaScript API. And it will, in the end, it will just be having this print message. Yeah, I don't know how good is this explanation. I will try. I tried my best. So basically, all the build tools, they produce not pure WebAssembly text like in here. You also have to have something in your JavaScript to help you execute that. And in this case, in a simple cases like yeah, adding two numbers, it shouldn't be very difficult, right? You just instantiate the model and it execute it normally. But when you write in more high-level programs, you'd like to have some helpers, and that's why you usually have this glue code in a JavaScript that helps you in the end to just manipulate normal functionality of your programming language. But that's not the scope again. That not changes how it pass in here. We just have to take it. Yeah, so this is my model. I can produce now WASM files. I can just execute this command. It will, with these flags, it will say that I want to be executed in JavaScript world. I would like to produce WASM model. So Go build does it. It will produce it in this directory, this file, and it will take this one and as a start model. I hope it will still work, right? Okay, so that produced a WASM file. Actually, I don't see it in Git changes because it was the same as it was in here. So that produced this main WASM file. That's fine. Then I also want to have something like that. This is also built-in Go functionality, which again adds some glue code in JavaScript to help you execute your WASM files. So you can think about that again. only like this example. So instead of doing this manually, most build tools and the Go build with the support of JavaScript flags will produce you this file, which does not much more than what this guy does in here. So it just executes a normal JavaScript API, but helps you with some methods and helps you with execution, but not more than that. All right. And yeah, after that, you just can serve your index.html file. I will show index and HTML file in a second. Let me call it in other port. So I'm just using some simple HTTP server. Okay, going good. Again, that's empty screen. I don't know if it's good or not. Yeah, this is the result. So basically, it shows that it can be executed already. That's good. That's good. Let's go to my model in here. Yeah, feel free to type the PizzaScript, your PizzaScript code. That's what we see in the console, right? So that's already quite good. What I have after, I have a print message, right? The print message is a method that was delivered by this model, and I executed this model, right? So now I should have it in that, and that's what we see in the screen. So let me show you now this index.html file, what it has, what's the difference, and in the end, it's kind of the same, right? It's the only thing this API is absolutely the same as we saw in a simple demo examples. What differs though is the part in here. So we have to call the this JavaScript library produced by Go build tool. So we just include this exec JavaScript file. It has just some JavaScript clue to simplify your execution, but it doesn't have anything with anything specific to Go World or to maybe I'm saying it wrong. Not with Go World, not something additional to WebAssembly, let's say, like that, not something specific to that. So anyways, that's how I initiate this library. And then I, instead of running it like I did in here, just calling the instance express.f, I have to pass it again to some JavaScript API produced by this guy. But that's it. The rest is absolute native code. Okay. Last but not least. So what I showed you, it's wasm.go. That's yeah, that was kind of breakthrough when I was preparing this demo, because yeah, the idea was in the end I want to compile my PizzaScript, my stupid PizzaScript language to WebAssembly, right? And then what I'm doing here, wasm.go. So basically, I'm compiling my PizzaScript compiler to WebAssembly. So it's a bit of metaphysics in here, right? I'm not compiling PizzaScript, I'm compiling PizzaScript compiler. And now, because I compiled my PizzaScript compiler, I can indeed on the fly compile my PizzaScript inside the browser to WebAssembly. How beautiful is that? Huh? It's just amazing. It's like I did introduced another layer. I didn't want that. I just wanted to try actually for demo reasons to show how to produce build model. And then I thought, yeah, I have a Go program, right? And the Go program is compiling PizzaScript. So why don't I build this one into the WebAssembly? And then I can export a function from out there that will compile in a browser, and I can execute it with the WebAssembly environments again. Yeah, amazing. Still can't believe it working. So yeah, that's my compiler, right? That's what my print message now contains. The print message, what it does, it just says, yeah, REPL is my PizzaScript request evaluate print loop message module. Sorry, please compile my input string. And that's what we saw in the other example before, right? I had this REPL starting. Let me demonstrate you that quickly, actually. Go run main go. All right, correct. It is still working. It does. So this guy is running on my local environment, and this guy is running on my web browser. And this is the same program. One is written in Go, and the other is also written in Go, but compiled to WebAssembly. And now actually this is producing some IST tree and then evaluating this IST tree. And this is a bit different. So I introduced this small function compile, which also has this lexer phase. It has a parser phase to create the abstract syntax tree for you. And it has just one small addition, which is print var. So remember, we had the IST to string when we stringified my my abstract syntax tree. This guy. Yeah, and before it was just showing some parsed numbers and parsed operators from my language here. And what I had to introduce is a very simple function for now, because that's what I that amount of time that I had. And what it does, it's just it produces something in WebAssembly instructions like that, and when it sees the number, it will use a I32 constant expression or statement, or type, and then it produces other constant, and then it says I want to add them if I meet the plus symbol here. Something like that. So it's a very simple piece of code in there, and it produces the correct or the valid WebAssembly modules. And then I had to do one more step. Basically, I already produced this WebAssembly modules in a WAT format, so WebAssembly text format, but I need to actually have a WASM format. And like I said, there are different tools that can transpile one format to another, vice versa. This tool that I specifically referenced to is called WebAssembly build tooling, or WABT. It's this guy here. So you can clone it, you can make it, and then you will have it on your console. And they also have a browser version, as you can imagine. So they did kind of what I did with my Go program, but they did it with WABT. So they actually provided this build tooling to browser as a WABT JavaScript file, and that's what I include in here. So that's what I have here. I just unloaded it from the registry, and I included it in my page, and then I transform in the WAT text file produced by my WebAssembly compiler to WSM file, and that's what my additional construct does here. That's my JavaScript function. It says, I'm gonna use this parsing or compiling function, print message it's called, very logical name. Then I'm using the build tooling to parse and compile WebAssembly text format to WebAssembly ASM format, initiating that, and in a similar way like we saw before, I'm calling the function out there. I call it add in here because it's still a bit dirty, but that's what my model looks like. So I produce this small modules. They have an exported function add, just like that, and it can execute the code in a way that we want it to. Right. It's almost it. How does it feel like? It's cool, right? Just to show you that finally, WASM eval, right? That's what my function is about. Colon 1 plus. It shows some of the modules in this WASM format, and then finally it executes it, but it executes it in a browser, and it executes it as WebAssembly. So that's. I think that concludes it. Oops. Right, just maybe to show you this one. So that just shows that it's all valid WebAssembly modules, and that was one of the goals of this project, to basically attach it and to see how can we build a compiled version of a program that can be executed in a browser, and that's what it does right now. However, my PizzaScript is still limited, as you know. It can just do some simple mathematical operations, but that is what it does. Yeah. Any questions? Applauses? Remarks?
A lot of applauses. Thanks, Alice,
Yeah.
for a great presentation. Yeah.
Yeah, welcome. So just to summarize, it's WebAssembly is a cool format that is can be executed in the browser, and in general, it should be more performant than JavaScript. It has all the sandboxes features of the JavaScript environment that we have. So it very safe by nature. It should be performant, as we said. Yeah, and you can compile PizzaScript to WebAssembly. Jesus Christ, that's amazing.
So PizzaScript should be added to this list that you showed us before.
Exactly. That's what I thought. I should just add a pull request.
Yeah, why not?
Yeah, true.
Awesome.
Yeah, that actually took not much time, this last step, and I thought it would be hard to achieve. I mean, it's very dirty code, you can see, but in the end, it does the thing that I originally wanted to try. It's so I'm very happy about that.
Cool. Yeah, we also have a question. Yeah, so have anyone of us heard about instant REPL website where you can try out different languages without having the code executed? I think you, Alex, showed us some kind of that website, or it was just a comparison of different languages. And you're
referencing to this one.
This one, and maybe I think some sessions ago you showed us also some comparison between different languages.
Yeah, I would say please maybe you can ask it's a bit with more context, because it depends basically what you mean. So indeed, we showed before like different IST representations when you can choose one format of IST and then compare it with the other IST format, or even transpile your programming code to any IST type, for example. We saw that. We also saw indeed the comparison of the languages itself. I have a very nice resource for that. Programming languages, is it still in my history? Languages. Yeah, I specifically like this one. It's a very nice table comparison of a different syntax first of languages. That what inspired my PizzaScript a lot. Like yeah, just choose the one syntax that you like the most from the table. That's how I basically started with the PizzaScript invention.
Mm-hmm. Yeah, maybe I'm just trying to imagine, maybe the idea of this question was maybe there's some website where you can kind of try out how it will work in WebAssembly, different languages. So if you put there C, Go, and so on, how fast and it's kind of.
Yeah.
Actually.
I think yeah, there is a Watson Explorer. I think Watson Fiddle, Watson Explorer maybe. Yeah, I think one of them was almost what you say. So we saw that one, right? That can compile C, C++. So that's just C versions. But this one, if I'm not mistaken, it has more abilities. Like you can actually start your project with maybe it was not that format. No. I don't remember now. I think I.
Yeah, but anyways, yeah, it should be enough. Great. Yeah.
Okay.
So, yeah, I think now I know much more than before.
About WebAssembly, yeah. How amazing
in general,
it is.
Yeah. At least WebAssembly.
Yeah. By the way, for the next sessions, just a little glance on that. That is mostly doing the full pass of this project. I wanted to add some more functionality, and that's, I think, the only one from original idea that is left. So extend my PizzaScript with more features like variables and yeah, maybe calling the functions, maybe improving a bit of code. Also, if you wanna, if you would like to help us to choose what should be the next session about, yeah, you're very welcome to use this form, and please submit your vote, and yeah, let's see what's gonna be next PizzaScript talk about.
Yeah, great. Cool. Thanks, Alex. I think that was an awesome presentation, and
thank you.
Yeah, also quite a lot of questions from our listeners. Thanks a lot for this.
Yeah, thanks for joining.
Yeah, I think we can just announce that again, every 2 weeks we have an event, and the next event will take place on the 22nd of May, right? Actually, it's my birthday, so it's gonna be fun.
Happy birthday.
Not yet. Yeah,
we're gonna party in that call.
Yeah, party online. Yeah, and for now, I think we know that it's gonna be a talk from Dima.
Yeah, let's not announce it again. Let's check it internally, and then yeah, follow our channels, and then yeah, we're gonna introduce it very soon.
Disclose it. Okay, I won't. Yeah. So yeah, thanks everyone for joining us this Saturday morning or afternoon.
Yeah.
And hope to see you again soon.
Enjoy your weekend,
Have a good weekend.
Yeah. See ya.
See you.
Bye.
See you. Bye-bye.